Spectacular Swift students, I'm Professor John Gallagher, and I think your Swifty stars are aligned because after you complete this 3-part beginner's intro on getting layout right in SwiftUI, the elements of your app will be aligned too. And along the way, we'll up your skills by giving you more Xcode tips.
If you're new here, welcome. You might want to check out the course playlist to see how we got here.
And because we're going to need a new project with some things to work with, why don't we issue a quick challenge? This should be super easy, but it's a great way to make sure that your learning is still on track and you're remembering things. So why don't you create a new Xcode project named Layouts, and create a text view with large font, heavy weight, and red color with standard padding. Have this display the contents of a string named message_string, which should be initially set to the empty string. Also include 2 buttons side by side, one saying awesome, the other saying great, and they should look like the button shown. And when the awesome button is clicked, the text view should say you are awesome, and when the great button is clicked, the text view should say you are great. So why don't you pause, give this a shot, it should be really easy for you at this point, and then resume, we'll compare answers, and continue with big learning. So launch Xcode, create a new project, this is an iOS app, click next, name this Layouts, I'm going to save mine to the desktop. I'll adjust my screen, and I'm going to start by entering my message string variable. At state private var message string equals. Now I did say that the message string should start out as an empty string, but if you want to just temporarily put a phrase in here, that might help you make sure that you've got your modifiers correct on your text view. And I'll start by deleting everything inside the VStack, and I'm going to add my text view, passing in message string, then the .font modifier in .large title format, .font weight passing in .heavy, .foreground style passing in .red, and .padding with nothing between the parens. Then I'll create my button. I'm going to select the option with title key in action. For the title key, this first one's going to say awesome. I'm going to tab over, press return on the action field to get the trailing closure format that I like so much. And in between parens, the action is going to be message string equals the string you are awesome exclamation point. Then I'm going to 2-finger click on the word button. I'm going to select embed in HStack. Then I'll copy the awesome button, paste it down below, but I'll change the button title to great. And when it's clicked, the message string should change to you are great. Below the HStack, I'll add one button style modifier. It'll be applied to both buttons, and that'll be button style passing in .bordered prominent. And I can try out those buttons, and things are looking good.
Now you might have noticed we start out with a blank text view, and our buttons are in the present position, but watch what happens when I press one of these buttons. So pay attention to where the buttons are right now. I'm going to press a button, and ho, did you see that? Both of the buttons seem to slide down just a bit, kind of like they were making room for the text view. Let's watch this again. I'll restart by clicking the live or play button in the lower left. You can also press Option Command P. And watch what happens when I click on one of these buttons. And yep, sure enough, those buttons are dropping down slightly. Now, if you've already got text in the text view, the buttons aren't going to shift. So when you click between awesome and great, there's no more shifting that happens. It only happens when we start out with an empty string in text, and then we add text that has some length to it. Well, having a user interface that jumps down from the user's finger after a press isn't usually the effect that we want in an app. What gives? Well, to see what happens, we're going to once again turn to our good buddy, the border modifier. So I'll add another modifier to our text view, saying .border. I'm going to select the option with content and width. The content is going to be .orange, and why don't we set the width to 2. And now let's look over to the right. We see a 2-point border around our text view. Now here's an important point about SwiftUI. SwiftUI will draw views so that they take up the minimum space required. That's why our text view is so small. In fact, there's nothing in the text view. The thing that we've drawn the border around is the padding modifier, since our border modifier comes after the padding modifier. So let's see what happens if we change the line up top where we initialize the state variable message string. And instead of the empty string, let's put in the string, hey there. And oh, we see that the text field grows in height because now there's something in the text field where there was nothing previously, just padding. Now that padding is around any space taken up by the text field, so that text takes up more space, pushing the buttons down. Cool. So drawing borders around things temporarily can be a useful debugging tool in that this is a good way to see how views are lining up or changing in size as the app runs. And I'll quickly toggle between having nothing in the string to something in the string, just so you can see that change taking place. Well, one way we can deal with this is to put something in the message string when we initialize it. Well, one quick hack would be to add a blank space to the string. It still looks empty, but the existence of a single space counts as a character, and that's enough to draw a view at a height that can accommodate the largest letters that we might type. So if I put a single space in message string, the buttons start at this lower position, and when I click a button and new text is put in there, the buttons don't jump. Well, this kind of works, but there are actually a bunch of reasons why we might not want to initialize message string with a single space. For example, we might test for an empty string at some point, and a space is not the same thing as an empty string. And this also doesn't solve the problem of if our text takes up multiple lines. For example, let's initialize the message string with a longer bit of text. How about fabulous? That's you. Whoa, we see that with the padding, this text takes up 2 lines and pushes the buttons down even further. So it would be nice if we could set up a fixed space to hold the text view, and this would remain the same no matter what's inside, an empty string or a 2-line string. Well, we can do that.
And you might already recognize that we need to leverage our other friend, the frame modifier.
Right after the border, I'll press return to create a new line.
Then I'll type .frame with WI and HE. That highlights the width and the height parameter. So when I press return, width and height are entered between the parens. I'll enter 300 for width, tab over, and 150 for height.
And now we see an orange border with a width of 1 around our text. And you might notice that the border is not around the frame. Why is that? Oh yeah, order matters. The border is around the text view and the frame comes after that. Well, what if we move the frame ahead of the border? Let's try that now. You can cut and paste the frame to move it up, or you can use the nifty Option Command open square bracket keyboard shortcut that we showed in an earlier video. So now the frame modifier is ahead of the border modifier. And bim scala boom, will you look at that? We see our frame bordered in orange because our border draws around the frame, not just the text view before it was framed. Nice. And just to try out, we can change the initialization back to the empty string. And now we see the button position doesn't change when the app restarts. That's because even though the text string is flat, it's inside of a fixed sized frame. But we can click on both buttons. We see things aren't changing because we've got a fixed frame in there, working just like we want. Now what if we try initializing message string to a string that's so big that it won't fit in the frame that we just drew? Well, let's replace message string with something long. How about, when the genius bar needs help, they call you. And gack! iOS can't fit everything in there, so it writes the ellipsis, that's the 3 dots, to suggest that there's more here than meets the eye. Now, it might be nice if we could adjust the font size down to fit the view if we need to, and we can. Behold, the modifier known as minimum scale factor. I'm going to add this bad boy just after font weight, so press return .minimum scale factor. As I start to type, it shows up in code completion. Code completion describes this as sets the minimum amount that the text in the view scales down to fit in the available space. Now, the number that we put in here for the factor is a number between 0, which scales it completely down to nothing, or 1, which does no scaling at all. I suggest 0.5. That means that if the text going into the view is too big for the view, iOS will scale down the font until it finds the perfect size to fit the text into the view, unless the size is smaller than 50% or half the original font size. And if you find that you need to scale your font down more than 50%, you might want to rethink your user interface. But now that I've got my minimum scale factor of 50% in there, let's see what happens in the text view. And ho-ho, the font size shrinks and all of my text can fit in there. Nice! Now another thing to point out, we see things look left justified when the text takes up more than 1 line. We see this with the Genius bar text, that's on 3 lines. If we click on awesome, we see you are awesome is left justified on 2 lines. But if we click on great, we see you are great is only on 1 line, and that looks centered.
But that's not really what's happening here. The text views are actually all left justified,
But the VStack and frames both have alignment parameters that default to center if they're not entered.
and the one-liners that are really left justified don't look that way because they're being centered. And this diagram might make this clearer. So what I've done here is I've drawn an extra border around the text view. That's the blue border. The orange border is the border that's around the frame. Now, all of these text views, the things in blue, are left justified, believe it or not. But you don't see it on these one-line guys here.
And the reason why you don't see that is everything inside a frame and a VStack are centered. So even if we didn't have a frame, we'd still have the text centered in the VStack.
See how the button H stack is centered? Well, when you center the one-line text views, even though they're left justified inside,
It's the frame and the VStack.
it's making it look like it's center justified when it's really left justified, but just in a tinier view. We'll see more of this in just a bit.
And just to show you, I'll change the initialization string to something really small like yo.
So both of the text views are left justified. It's just that they're also being centered by the text view, so yo looks like it's centered when it's not. Now, I like having all of my views centered in the VStack, but what I'd also like to do is to center justify all the text inside of the text views.
But my friends, do you think that we've got a way to align multiple lines of text? I bet you guessed, yes, we've got a modifier for that, and you would be right. So I'm going to enter this right underneath the minimum scale factor modifier. So what we want to do is we want to fix the alignment for multiple lines of text. Now always remember, if you forget a modifier name, you can try to guess this. So if you remembered, oh, I forget the modifier for multiple lines of text, but I know it has alignment in there. If you type .alignment and look at code completion, sure enough, we see multi-line text alignment. The description says,
sets the alignment of a text view that contains multiple lines of text.
That sounds just like what we want. It takes one parameter, a text alignment type. Does Xcode offer code completion with predefined text alignment types? I'm going to press return to accept this option. Then in the alignment parameter, I'm going to type period, and boom, it does. We see options that include leading, center, trailing. Leading is left justified, trailing is right. We want center, so let's choose that. Let's check out the preview. We'll click the awesome button. You are awesome is on 2 lines, but now it's centered aligned. Thanks to the multi-line text modifier we just added. Slick. Now what if we change the alignment property to, try dot trailing, click awesome, and look at that, dot trailing is right justified. But we of course want center, so I'm going to set it back to center. Looking good. Now let's explore more how things are spaced out and how we might be able to change that. We've already seen the dot padding modifier we're using on text. Let's see how things look if we get rid of that modifier. I'm just going to comment out this line. You can put 2 slash characters in front of the padding line, or you can hold down Command and press slash to toggle comments on or off. And we don't notice a difference. Why? Because we already have a frame which adds a fixed size around the text view. But let's comment out the frame and see how things look. Look at that. Much more interesting. We see things get much smaller. Now, why don't we put a border around the H-stack so we can see how much space is between the text view and the H-stack's frame. So I'm going to copy the border modifier from text view, and I'm going to paste it below H-stack. And that'll add a border around the H-stack so we can see where the H-stack is relative to the buttons. Again, we don't have a frame on this, so any frame would be given default by SwiftUI. And so we can see this better. Why don't we set the color to purple and the width to 5? So that border is drawn around the H-stack. Remember, that's provided by SwiftUI. We did not create a separate frame for this particular H-stack. And curiously, we see that there is some default spacing between the 2 views, but we didn't add any. Well, iOS assumes that you want some spacing because having things squished directly together, one on top of the other, isn't usually a good design. But just to show you, it is possible to override the default spacing if you don't want any space. So after we write VStack up top, we can actually put in some parentheses with parameters in there. We don't have any right now, but we can add them. So I'll add an open and close parenthesis, and in between, VStack actually accepts a spacing parameter. And it's kind of cool. As soon as I start to type that, we see some help and code completion showing up, and I can verify, yep, there is a spacing parameter in here that accepts a CG float. That's just a number. Now, in order to add this, we actually have to type the label name spacing with a colon, all in lowercase, and then we follow this by the number of points of spacing we want. And if we add a 0 in here, boom, we see that the frame of the text view and the frame of the H-stack are right next to each other because there is 0 amount of space in between them. Cool. Now at this point you might be wondering, how can I find out about these extra options like the optional parameters you can pass into a VStack? Well, let me show you. One way is to command click on a term. Then Xcode says that I can either jump to the definition or the initializer. I'll choose the first option for VStack, not the initializer. And then what we see here is Apple's actual definition for the VStack data structure. So we're looking at the actual code that defines this structure in SwiftUI. Now it can initially seem overwhelming when you see all this stuff because there are a lot of terms that we haven't covered yet. Available, frozen, public. But look to the comments here. This stuff is gold. Now you get a description in the comment. This creates an instance with a given spacing and horizontal alignment. You see a description of the 3 parameters, alignment, spacing, content, and you see the init down here. This tells you how a new VStack is created or initialized. And again, the syntax is unfamiliar to us because we haven't covered much. We're early on in the course. But one thing to point out is what to look for to see if parameters have default values. You see how the first parameter, alignment colon horizontal alignment, is is followed by equals.center, well, that means that if there's no alignment parameter offered and we haven't added one yet, then the default is center. So that's why our single line of code was defaulting to the center alignment. Now, spacing has a default value of nil, which means no value, not 0. But in the description for the spacing parameter, it says that spacing is the distance between adjacent subviews. Or nil if you want the stack to choose a default distance for each pair of subviews. So if you have nothing in here, then it'll work with its default distance for spacing. And content is simply our closure. The closure is just the lines of code between curly braces. Remember in the prior video when we used code completion and the content parameter showed parentheses and arrow and void, and when we double clicked on that, Xcode wrote the open and closing curlies in the trailing closure format. Well, that's how we've been entering a VStack when we typed it in directly, and that's how you'll usually be entering it. But just to show you, you can enter a new VStack using this longer format. Now remember, we jumped to definition, so to get back to our code, we can just press this back arrow button, almost like you would in a browser. That's located in the upper left-hand corner, just below the traffic lights. And you know what? Before I show you the VStack with all the parameters, I'm going to get rid of the spacing in between the parentheses here. We actually don't want that. I was just showing you how you can set spacing to 0 if you needed to. And so just above the existing VStack, I'm going to call up another VStack and have Xcode fill this in with all the parameters and with the traditional format for the closure at the end. And look at this, alignment and spacing are dim, but if we want to include these, we hold down the Option and press Return. Now first we can convert the content area to the trailing closure format. Now I could tab over to the content input and press Return, but instead what I'm going to do is I'm just going to double click on this area that has the parentheses and the arrow, and this will get rid of the content label and it'll write the closure in trailing closure format with the open and close curlies and the end parenthesis after the spacing parameter before the opening curly. Now from here you could go back and enter any of the parameters if you wanted to. So if you wanted an alignment, you could use dot notation to pull that up, or you could delete it. And for spacing, if you wanted to put a 0 in there like we had before, you could leave spacing in with the parentheses. Otherwise, if you wanted to use the default values, you could get rid of the parentheses and any of the values that were inside of them. And that's what we're doing below down here. We've got a VStack that just has a closure, and since we don't have the parentheses with either of the two parameter values, then we just use the default values. So that's our very first look at jump to definition. Again, there was a lot of complexity in there, but you're eventually going to feel more comfortable taking a look at the documentation, and even though there's a lot you don't understand, bit by bit if you go back, you'll find you're learning and understanding more and more each time you visit it. And it really is a good resource, so definitely know this exists and check it out frequently to improve your understanding of Swift and SwiftUI. And since our code is getting longer with blocks of code for the VStack, HStack, and buttons,
It's worth remembering code folding, which you can use to find the beginning and ending of any code segments.
now you see this area just to the right of the line numbers on the left-hand side? That's called the code folding ribbon. Well, when you move your cursor into the code folding ribbon area, you'll see a down pointing arrow. This indicates the start of the code block that's just to the right of the cursor. So here we see that this starts the VStack code block. Now if you click in this area, the code will fold up. Cool, huh? Now you can see the line numbers go from
18 to 40.
everything in between is still there, but the 3 dots between the curlies after VStack say everything in the VStack's closure is now collapsed into code folding. Want the code back? You can either double click on the 3 dots, sometimes called an ellipsis, or you can click the right pointing arrow, sometimes called a chevron, and the code will unfold. Very cool. And you can fold code inside any code block. So I can click in the code folding ribbon just to the left of the first button here, and that button code folds up. I can fold the button code for the second button. I can fold up there enclosing HStack. So you can experiment with this. I'm going to unfold everything, but you'll likely find this very handy. And by the way, there are keyboard shortcuts for this too. Option Command left arrow folds the current block of code. Option Command right arrow unfolds it. Cool. And we just use this VStack to demonstrate some concepts, so we can highlight it and delete this first one. Now back in the VStack we created before, I actually do want the padding and the frame to show up. So I'll highlight these 2 lines and type Command/, and that will remove the 2 comments that we have here. You should see the preview once again shows our nice frame.
Up next, let's create a flexible width frame. Now, we've defined the width of the text view as a fixed width, but sometimes you don't want to do this.
You might instead want to take up all the available space, in this case the width of the device.
This way the frame could get wider or thinner depending on the device width. To show what I mean, I'm going to change the start message string back to when the Genius Bar needs help, they call you.
And then I'll switch to a larger device for my preview.
And then at the bottom of the preview, I'll select the largest device from the preview device icon, and I'll select the biggest iPad that's in here.
And it may take up to a minute to show this the first time you switch to an iPad.
My preview switched to an iPad, but it's outside of the lines. You can't really see it. So I'm going to go down here and use my zoom icons to fit it into the available space.
And what we see is a smaller rectangle, which is the fixed text frame around a lot of free space on the device. Well, instead of defining our frame with a fixed width and height, we can actually use another option when defining a frame. And this option will let us set a variety of different flexible widths or heights to stretch or contract the dimensions of the frame. And what's really useful is you can combine the frame definition statements and use only the pieces that you need, fixed for some dimensions, flexible for others. Let's do this together. I'm going to modify my text frame here so that it only includes the fixed height, and I'll keep the height at 150 regardless of the device I'm running on. And when I remove the width, we see that the frame resized to the width of the text itself. But below this, I'm going to add another frame modifier. And as I go below that first frame definition line, I'm going to type .frame and look at this second option down here with lots of input parameters. Now these parameters are optional, and you can feel free to return and experiment with the min and ideal values later. And we already talked about how the alignment works, but for now, I'm going to select max width. So if I type MAXWI, I can see that that parameter becomes highlighted. When I press return, I get the frame modifier with the max width parameter. And for my max width value, I'm going to enter .infinity. Now that'll space out the max width to the maximum available in the view that this view is inside of, and for the text view, that's the width of the device. So these two frame modifiers work together. The first one sets a fixed height, the second one sets a flexible width. The width is stretched out right to the ends of the device. That's further than where it was previously. Nice. Now we do have some padding that you can see at the end of the frame, and that's because I've got a padding modifier at the end of my VStack, so I'm going to delete that now. And now we see the text view frame is touching the sides of the device. That's because our frame width is .infinity. And the reason we see things this way is because modifier order matters, and our padding modifier is currently before our frame and our border modifiers. So let's move our padding modifier to the end of our list of modifiers, and now we see we've got a bit of padding around our frame too. Nice! And you can try this with different size devices on your list. The smallest device, this is the SE version 3. Then I'll go back to the flagship iPhone. Everything's looking good. Well, we've already learned a lot in this video, and this was only part 1 of our multi-part intro to getting layout right in SwiftUI. We learned about the border modifier, and we added borders to our view so that we can see their size rendered on screen. We learned SwiftUI only uses the minimum space required for views. We learned to use the .frame modifier and how to use both fixed and variable dimensions in our frames. We learned how to set the dimension to the maximum available space using .infinity. We used .minimum scale factor to resize a font to fit within a view. We learned to use the multi-line text alignment modifier to align text with multiple lines, and we learned about the alignment parameter and that it can be used to align objects within a frame or stack. We also learned how to use the spacing parameter to eliminate spacing between items in a stack, and we learned how to view the definitions of Swift and SwiftUI data structures and to read these to determine if they include default values and even find out what those values are. And we learned lots of tips and tricks along the way. Some of these concepts are pretty sophisticated, but I hope you are feeling good about your growing base of knowledge, Swifter. Come back in the next video for part 2 of our beginner's intro to getting layout right in SwiftUI. Keep hacking.